What is good, you guys? I am Jaideep and welcome back to the channel. Right, before we begin this video, a gentle request: do watch this video entirely. It will help me make up some of the watch hours. And if you are new to the channel, do subscribe it. Do share the content with your feeds, not feeds, but yeah, share it on your feeds as well. Share it with your friends as well, and do leave your kind feedback in the comment section below. So, with that being said, let's get started. It works on my machine. This is a statement which you would hear commonly even nowadays, or more so 10 years back, when code which was developed by developers on their local environment and given to testing or promoted to QA or test environments would not work the same. Why? Because of the setup issues. So the developers developed the code using certain packages, certain binaries, certain libraries, certain dependencies, and environment or the same setup had to be replicated on the tester's machine or on the QA environment or any higher environment. Doing this is not a trivial job. And the solution to this problem came about when containerization technology started taking center stage in 2013. In this video, we're going to look at one such containerization technology is Docker. It's not the only one, but it is one of the pioneers who started the whole containerization revolution and how to run end-to-end tests using Playwright and Docker. To give a quick introduction about Playwright, if you're from the web automation testing world and you're aware of Selenium, Playwright is a competitor to it. So Playwright was developed by Microsoft in 2020 and it is one of the newest entrants in the web end-to-end testing world and web automation or browser automation. I have a detailed tutorial for Playwright and how to install it, how to set it up and how to use its Python API. So the important thing about Playwright is it has Java APIs, it has TypeScript, it has JavaScript and .NET APIs. So it doesn't matter which language you're coming from, as long as you are okay with any of these 4 or 5 languages, you can use Playwright to write your test cases for your web-based applications. So I'll leave a link to the description. So I will leave a link to the video on Playwright on my channel in the I button and in the description as well. Do check that out, and we'll move on to the gist of this video, and how to write end-to-end test cases using Playwright and Docker. So what is Docker? A detailed video series on Docker, what problem it solves, how it solves it, and how it can be useful or how it has changed the development or the software development industry is a work in progress, and that will be out sometime soon. But I'll give a quick introduction about what is a containerization technologies. So what it does is it bundles the application, all its dependencies. So consider you write a Python application or you write a Flask app which uses Python 3.8, Flask 2.2.1 and certain other packages. So instead of pushing a requirements.txt and all the code together, we bundle everything in something called as an image. This image is generated using a Docker file, and using this Docker file, we can spawn an application instance, which is called a Docker container. So instead of pulling all the code and then installing all the dependencies and then running the tests and stuff like that, what you can do is you can download the Docker image and just run a container. Everything, all the application packages, all the application dependencies, binaries will come bundled together as part of that image. So this solves the problem of having inconsistencies within development environment. That we know what Playwright is and quick introduction of what Docker is, let us move on to the gist of today's video, which is writing end-to-end test cases using Playwright and Docker. So my constant endeavor is to use the best practices which are available, and hence to write the test cases, we are going to use a design pattern called as page object models. What page object model does is, if you're familiar with object-oriented programming, this represents an entire page under test as an object. So all the tests for that particular page will be written in the same class. So all the tests for one particular page are grouped together. They provide a better structure, and anyone who joins the team again can just extend these test cases by writing these test cases or grouping them together in the same class. So that is the page object model. So if you're writing tests for, say, getting started page, not getting started, but installation, then you can call this page object as installation page. Similarly, writing tests page, running tests page. So all the test cases for each and every page can be grouped together, and that can be done using the page object. So we'll be using this design pattern to group our tests together and keep them well structured. So in summary, page object model helps us group together tests which are related. That is, by related, I mean they belong to a single page, and any future tests for that particular page can be written in the same class. The test website which you're going to use is called the e-commerce playground LambdaTest. Let us now look at the project structure. So it contains one class per page under test. If you see, this has a home page. This is the home page. This has the my account page, and then if you go to individual product, there is a product page. So each and every page is represented as a Python class, and that is about page object models as well. Each and every page is represented as a Python class, and in the Python class you group the relevant method together. So for all tests which you write on the home page, you can just write it in this class. So all the tests will be grouped together. Similarly, product page and the account page as well. Playwright uses PyTest as its preferred testing Python framework. So as I mentioned, you can use Playwright using Python, JavaScript, Java, .NET, and TypeScript. So we're going to use the Python variant because obviously this channel is more about Python. It's about tech, but it's about Python. And if you aren't aware about what PyTest is, I do have a detailed tutorial. Now, the test has a conf.test.py. It stores all the PyTest fixtures which can be used globally across our test cases. So fixtures provide tiered setup and tear down code. So any code which you're going to need across multiple test cases and it's going to be needed repetitively, you can group together in a function. You can give the @pytest.fixture decorator and give it a name. So if you don't want to use this name, you can give the fixture a name as well. And then this fixture or this function can be simply used anywhere. So if you see, we are using the browser or this fixture in all the subsequent fixtures. So yes, a fixture can be passed as a parameter to another fixture as well. So we have 4 fixtures in total, one for the account page, one for the home page, one for the product page, and one for initializing the browser. Interesting bit which you might notice here is this code is designed to run on local and it can run on cloud grid as well. So why cloud grid is, so I have a Windows 10 machine and I have the Chrome browser. Additionally, I have Microsoft Edge and I can maybe install Firefox. But if I want to run the test cases on a different operating system, say Linux or Mac OS, and a different combination of browsers, I cannot do that unless I get a physical machine. And to do that, or to enable that, what we can do is, so we can leverage providers such as LambdaTest, which have their whole grid infrastructure, which provide cloud grid infrastructure for running test cases. So if I go to this automation and builds, and you can see that we can leverage the platform or we can leverage their infrastructure to run test cases on different environments. So if you see here, this small icon, Mac OS and Safari or WebKit browser, which basically powers Safari. So yes, the fixture then, so what this fixture does is it returns a browser instance. If you pass the environment variable as local, it will run the test locally. If you pass it as cloud, then it will connect to LambdaTest and run the code on their infrastructure. And the next subsequent fixtures are the account page, the home page, and the product page. So we saw in the class that this needs a page instance, right? So this is a Playwright page. Basically, this is a page instance, right? This is a Chrome web page, yeah. And to navigate anywhere, we need this page. If this tab is not open, we cannot navigate. So similarly, to run the test cases, each and every class or each and every page object requires a page instance, and that is done by these fixtures. So if I open the test account page, you see all these test cases are running on a page instance. Now we can initialize these pages locally within these tests, but that is not a good practice, and hence we have created fixtures for each and every class, and then we can just reuse this. So if I go to test account page, it takes an account page fixture as an input. Each and every test takes an account page input or the account page fixture as a parameter, and on that page we can call in the methods. So that is what this does, yeah. Each and every class or each and every page object has its own fixture, and that fixture generates nothing but an instance of the home page, and that is given back on which we can run the tests. The utilities is certain reusable functions. So this set test status. So if I go back to LambdaTest and if I open one of the tests, you see use coupon code is available passed. So this set test status is the function which is responsible for adding this title and the status of the test. So if you notice carefully here, we are calling, not here, but here, in each and every test, we're calling the set test status. And based on whether the test is successful or it is not, yeah, this one. So search button is not visible, failed. So depending on whether that's come from here, so search button is visible and not visible, so search button is not visible. So this is what set test status does. And the last one is this capabilities dictionary, and what it does is it decides the infrastructure which the test is going to run on. The browser, the platform is nothing but the operating system, and build and name. So here the test name, it comes from here, Playwright Docker test for platform and browser. And the build, so the name which was here, this one, it comes from here. And the other parameters, network, video, visual, console, these determine the other factors. So if you see, if you want the video, you can set the visual to video to true. If you want the screenshots, you can set the visuals to true, and stuff like that. I think we have covered the project directory, or the so this was supposed to be a project directory walkthrough, but I think we have covered some classes as well. But let us now look at one of the page objects, or one page class, and the corresponding test. So to keep this tutorial short and to the point, we'll look at the tests which we have written for the home page. And the home page class has three methods. So I think 1, 2, 3, and the init method. So the init method takes in the page and then creates two instance attributes, search button locator and my account link locator. And what is a playwright locator? So playwright locator is nothing but a way using which you can locate elements on the web page. Now if I open the demo test, or the demo website which you're going to use, the home page of that, we can see search. So if I right click on this and do inspect, sorry for that, and if I just do right click and inspect, and if I dock it to the bottom, and if I go and inspect again, so if you see, this search is a button, so it has an HTML role or an ARIA role button, and the text or the name for that is search. So playwright locators allow, so there are 6 or 7 types of playwright locators. There's a detailed tutorial for that coming up as well, and I've written a blog about that as well, about how to locate elements using playwright on and its Python APIs. So I leave a link to that. So I leave a link to the blog in the description. Do check that out as well, and that explains what these locators are. Is a link. Okay, so here it's a link and it has an href attribute which navigates to the /account page. So that is what we've done. This is a link, and then this is a name, my account. So if you see the name here, my account, yeah. So that is what we have done here. Search, get the role, initialize a locator, initialize an instance attribute using the page.getByRole locator. Yeah. So this is the init method. Now the navigate method is pretty simple. What it does is, on the page instance, we call the goto method. And playwright page.goto takes us to the e-commerce, takes us to the homepage of our website. So this is the homepage of our website. So if I go here, and not here, but this one, and I close this for a minute. So this is what we're doing. Essentially, the action which you did here. This is what we're doing using page.goto. So goto is a playwright page method. And then using these two locators, we write search button and my account link. Now I agree that I could have done a bit of better job using in naming this, but what the search button does is, on this located element, so we found this element, right? Or at least assume that we found this element to be visible. Now we know by inspection of I that this search button is visible, but we have to write test cases. We cannot be, that is the whole goal of writing automation tests, right? So next time, if there's any changes to this homepage, we should be able to run this test suite and we reliably verify or reliably say that, okay, the search button is present. So expect is nothing but a playwright sync API, another playwright sync method, or a playwright API method, which expects the search button locator or the element located by this search button locator to be visible. So on the located element we expect this to be visible. So it's simple and plain English. Expect that this element to be visible. So if it's visible, we write search button is visible. If not, search button is not visible. Yeah. Similarly, my account link, expect that this element located using this locator to have an attribute href, and the link to that, or the link within that href, would be this my account. Again, you can make this as a regular expression. So we know that, we saw that a couple of minutes ago, that okay, my account is a link and that it has an href and an account, and the link redirects to the /account. So this is let me minimize this a bit so that it fits in one. Yeah, I think it now fits a bit. This one I think is good. So this is how the page object model test. So this is how the page object, or this is how the entire page or the tests which we're going to write on page have been structured. So all the tests which are corresponding to the home page. So tomorrow, if you want to write tests for home, special, blog, mega menu, add-ons, or anything on this page, you can just write the locator here. You can write it here, or you can use an add property decorator and make it as a new property. And using that locator, you can write more methods to test whether whatever you're testing. So to be visible, to not be visible. So for example, if we say there's nothing called as, say, an add to cart. I think there's a checkout button or cart button, but there is a shop now button as well. So if you want to see that, say tomorrow the search functionality was removed here, then you can just simply rewrite this test as to underscore or not underscore to underscore be visible. Yeah, so it's easy to do that as well. So there's a number of methods or number of assertions which are available, and using that you can reliably write test cases for this particular web page. Similarly, for the account page, we have locators for, so if I show you the account page, if I go to account page, this has a new customer registration, a returning customer and a returning customer login. So if you see this, this is a link and this is an email and a password. So when you log in, you can log in using email and password. So this is what we've done. New registration link locator. If I just inspect this, so this is a link. So this is what I've done. Role is equal to link and continue. This is a continue text. And similarly, email address and password. So if I inspect this, so this has a placeholder called as email address. So instead of getting by role, we have changed the locator, Playwright locator, to get by placeholder. So again, if you are not aware what these locators are, I have a detailed blog for that, and I'll leave a link to that in the description, and you'll see an image somewhere popping here, I don't know, somewhere on the screen. Do check out that that blog. I've explained each and every locator which is available in Playwright. And yeah, also because we're talking about checking out stuff and checking out blogs, if you're new to the channel, do consider subscribing. If you haven't already done so, do leave a like and do leave the comments do leave your feedback in the comment section. It helps me keep motivated, and it's also good for the algorithm. Obviously we crossed the 1000 followers, but we still need a bit of watch time, so do your bit for the algorithm, and if you find this content useful. But yeah, moving on. So here we have written the new registration link, email field, password field, forgotten. So I think one more test here. If I just inspect this forgotten password, this is again an HTML href or HTML a tag or a link tag, and it has a text forgotten password. So get by role, link, name is equal to forgotten password and exact. So if you see here, forgotten password and forgotten password is available here as well. And if I inspect this here, and if I just minimize this, so forgotten password here has a small space. So it matches essentially this. If I give name is equal to forgotten password, it will match to this and this as well. To prevent that, I've given exact is equal to true, and we've only been saved by, because there's a space here. And if I inspect this, there's no space here. So if there was if there was no space in this forgotten password, then this would have matched to two elements, and we would have further needed to narrow down this search or narrow down this location. But luckily, because there's a space here, we got away by setting exact is equal to true. Again, this might be a little bit abstract, or this might be a little bit too much to grasp, but that blog on Playwright locators is, that is the one which you want to check out before this. And then again, navigate is similar to what we had here. Instead of going to the home page, what you're going to do is go to the account login page, and then the methods are very same. So this is home page, account page, and product page is really the same. All of our core logic to go to this web page, locate these elements, do the assertions has been written in the class homepage class. Our test homepage just involves getting the browser instance or getting the page instance using on this browser, and then calling the navigate method. So if I call the navigate here, it will first open this website. Then search button. So what is search button? So what the search button will do is it'll get this locator and see if it's visible or not. If it's visible, it'll run the test case accordingly. It'll run the test case, and based on the output, then it'll either come out true or false. And then we close the browser. Similarly, test homepage contains my account link. we call the navigate, then my account link. So instead of calling the search button, we'll call the second test function and then closing the browser. We'll first run this test locally to make sure these are all working. I know they are working, but just to show you how to run these, pytest hyphen, or not pytest, but pytest hyphen v. So pytest hyphen v. Now by nomenclature, again, if you are not sure about what pytest, or not 100, or you aren't that well versed with pytest hyphen v will look for this tests folder and anything which is named test underscore. So anything within this, it will run automatically. Yeah. So if I do this, you see it has collected 8 tests because we have 1, 2 here, we have 3, 4, 5 here, 6, 7, 8 tests here. Yeah. And contains registration link. So it has errored out, but I think we'll see. So this is passed out. So let's see why the current test is failing for some reason, but I think we can look at what is happening. Right. So if you noticed here, what we're doing is essentially we're reading the platform browser and run on. So this fixture or this browser instance will be returned based on the environment variable run on. So it has been defaulted to run on local. Now, what I can do is I'll just try to rerun this again. And instead of running, so I'll go in the test state, and instead of running all the tests, what I'll do is pytest hyphen v is for the verbose and test underscore homepage. So we'll run just the 2 test cases first. So if you see in the test homepage, we had only 2 tests. So hopefully both of these should pass, but let's see what happens. So both of them hopefully pass. Yep. Now pytest hyphen v test underscore account page. Now test account page has 1, 2 and 3 tests. So let's see what happens. So this is also passed. This is also passed. And this is also passed. And similarly, I can just do this test and product page. So account page, continue forgotten password. Home page contains search and my account, and product page contains add to cart buy now. So yeah, just to give you an idea about what the product page is, on the product we're checking if the add to cart is present, buy now is present, and once we check out whether this checkout text is present. So that is what we're checking. Yeah. And then all the tests are running, and then I can just do cd. I can come back and do pytest hyphen v. And then let's run all the 8 test cases again. I think they should, this time they should pass. First time there was some maybe setup issue. When it runs for the first time, it does take a bit of time sometimes to kind of get the whole environment in sync. Remember, these tests have been defaulted to run on local only. Yeah. But we're going to see in a moment how we can Dockerize these tests and then run them on a cloud grid such as LambdaTest. So again, you have to sign up for the LambdaTest platform. The sign up process is very easy. Do give them a try. It's a nice and a handy platform. But yeah, do give them a try as well. So these tests are running. Now we want to Dockerize them. Another important thing is if you want to run these tests in parallel. So 8 tests are not much, but if you want to run them in parallel, what you can do is pytest hyphen v double hyphen num processes and say 3 tests at a time. So you need the pytest x dist library for that. It comes in installed with the pytest, but you see because we started 3 processes, and this is based on your CPU entirely. So I have a i7 7 core 12 generation processor. So I think three instances or 3 worker threads work fine for me, and the tests will run in parallel. So this is about the whole setup of running your tests locally or without Dockerization. Now again, the problem is if you see requirements.txt, I have so many requirements. Yeah, so many requirements, around 25 requirements. Now if I push the code as it is to the GitHub, then someone has to clone this environment. Now here I'm using a virtual environment called as Docker Playwright. I've created it using Miniconda. So if you're not sure about Miniconda is, or if your concepts about environment and package management are not that clear, do check out my video on the package management and environment using Miniconda, and that would give you an idea about what this is. But yeah, coming back, if you give this code to someone, they'll have to install so many libraries, and if you forget the versions in one of them, or one of the version goes wrong, then the tests won't run. What is the solution for this? The solution for this is Dockerizing this entire thing. So instead of running the tests locally, convert this whole code base into a Docker image, push the Docker image, and then what your testers or what your fellow developers or fellow team members can do is pull the image, spawn up a container. Container is nothing but a running instance of your application. So in our case, the running instance of our test cases, and then run these test cases. So whatever test cases you have written, whatever requirements or whatever Python packages you have written or packages you've used rather, they'll be bundled together in a Python in a Docker image. Docker image is what we call them, and then just deploy the Docker image. The Docker image can be pulled by anyone, and you can spawn up a container and then run the container, and that gives you the consistency which you need for to run the test cases similarly or seamlessly across any machine. That won't give you any problem. So next, let's move on to the Docker file, how to create the image, how to run the container, and then we'll end this tutorial with how to run the test cases on a cloud grid such as LambdaTest. Right. Now, moving on to Docker images and Docker containers. So what is a Docker image? You bundle everything together and that gives you Docker image. Now, to create a Docker image, what you need is to install Docker, obviously. And the way to install Docker is not by starting Chrome, but by going to Docker. And you can just type Docker, and then you can download Docker Desktop for Windows. So Docker Desktop for Windows will give you something which looks like this. This is Docker Desktop. And then if I also go to, actually, I don't even need to go here. Docker version. So yeah, it'll give me a Docker daemon as well. Now, if you're interested in the Docker architecture, again, I keep starting, I'm still getting used to Windows 11, so I keep starting multiple tabs. But I can just do Docker architecture and this one. Yeah. Okay, not looking good. This one. So Docker host, Docker client, and registry. So as I mentioned, the Docker host is the host machine. So this is our Windows machine where the Docker is running. Docker client. This is where did it go? Here. So this is the Docker client. So on my machine, when I start this up, actually it started up very nicely. Now, if it doesn't start up, what you can do is you can go to, I have a tutorial. So it's funny actually, installing Docker on Windows is a bit of a task because Docker is traditionally written to run on Linux based machines or Linux based kernels. And Windows has now WSL2, Windows subsystem for Linux, and it supports Docker nicely, but it's a problem that sometimes this Docker doesn't start. And what you can do is then in that case, I keep opening Windows on my second machine, just to WSL version. And if you see, so this WSL, I think, yeah. So if you see WSL, my WSL version 2 is running. Yeah. So I have WSL version 1 and WSL version 2 as well, but WSL 2 is running. This is the latest Windows subsystem for Linux. So if this Docker, once you install Docker obviously, and it doesn't start up, what you can do is I leave a link to one of the videos which I did on, again, this is the fourth time I've opened, do I have my YouTube channel open? YouTube and your channel. This one. Yeah. So solve Docker desktop problems. So this, let me actually play this. So this was recorded on Windows 10. This was my previous laptop, but it still says the same. Yeah. So here, if you see this yellow screen or Chrome screen instead of the nice green one, do watch this video. Okay, it has 1.9k views, so it's a problem which a lot of people are facing, and so nice step, so nice comments as well. Do check out that video as well. So that is Docker client, Docker host, and Docker registry. So what is Docker registry? Once we create, so if you're from the Python world or you're from the Java world, you have Maven, right? Or you have PyPy. So when these all images are created, where do you store them? You can store them in a registry which is called as Docker Hub. The Docker Hub, I have to sign in. I sign in and come back. So wait a minute. Yep. So if you see, I have a Docker image as well. So explore. And if you see, there are a lot of images which are already pushed, so you can just pull out any of these. So there's a official Python image as well, there's Ubuntu, Nginx, and stuff like that. So if you see, Python has so many images, and depending on the version, so 3.12 is already available actually here. And this tags or versions are nothing but kind of identifier of the particular version. So this is the Docker Hub. You can pull images from here. So if you run the command, say again, I think I might have spawned this up in the wrong. Yeah, if I do docker pull Python, and let me pull a very small one. Let's see, Alpine. Yeah, so this 3.11 Alpine, this looks like a small. So Alpine ones are the small ones, are the bare minimum one, using default tag as the latest. I think I repository. Okay, so it needs me to log in, but if you do okay, so it's pulling the latest version, and that is what it is doing essentially. Whichever is the latest available here, that image would be pulled up. Run certain commands to see all the images which are residing on your machine. So if you see, it's a pretty large image, and that is why I prefer the Alpine one, but I think I'm messing up the command a bit. I think I don't remember honestly all the commands. I'll probably use ChatGPT for this. But if you want to see all the images, what you can do is docker image ls. So if you see the Python image 3 days ago, 925 MB, damn. And this Playwright one, which I prepared, this is 1.89 gigs. So I need to delete this after the video. But yeah, that is about Docker pull. So client is the one which is running on your machine, as I showed you here. So this is the Docker client. This is the Docker desktop or the Docker host, and this client in this hub, or this desktop actually interacts with this client. Yeah. Now we saw this Python image, right? And we are seeing a Playwright image as well. How was this image built? Now to build that, you need a special file, and it is called as I know it is called Docker file, but I need to find it here. This is the exact syntax, and you see this nice little plus this wheel. Yeah, or it's called Mobi actually, but yeah, it's Docker symbol. So this is how we write a Docker file. Now Playwright has its own official Docker image, so which has Python and the browsers baked in. So all the tests which we ran were run using, if I go here, I think if I'm not wrong, Chromium, not here but here. Yeah. So we're using Chrome version, but you can have other browsers, as I mentioned. You can, if you don't use the syntax and if you simply yield a page, you can use any browser as well. So this Docker file pulls up the Playwright official Python image. Back, not to deviate from the topic, pull up this image, pull this image from Docker Hub, work directory, create an /app directory. So this is more like making mkdir. Sorry about that. The work dir is just like this, firing the mkdir command, and then this pages, tests, and utilities. Obviously, we're copying it within app, pages, test, and utilities. Then we copy the requirement.txt as well. So here, what we normally do is we push the requirement.txt, then we expect the testers to just install this from the requirement.txt. But sometimes people don't follow instructions, they install the stuff on their own, and this is where the discrepancy happens. But how is Docker solving this? Everything which is needed, instead of pushing all these things separately along with this requirements to the GitHub, and then people downloading all these three and then making sure the environment is consistent, you bake all things together. So if you see, once a requirement is copied, you're also installing it. Yeah. So pip install -r requirements.txt, and now what you can do is docker build -t playwright yt docker demo and not dot, but I think because the file is not here, so to go one directory up, and now if I do dir, Docker file is here. So not Playwright but pls docker build -t, give it a name. So I'll give it Playwright yt demo, Playwright yt, or Playwright docker yt demo, and dot simply means that the Docker file is located here. So if you see, it's now installing. So it's done all the transfers. So the copy is done, the copy of requirements is done, and all the installation is done. And now if I do docker image ls, if you see Playwright docker yt image is there. So all this code is now synced into this 1.89 GB, it's large, but that is because it packs in a lot of browsers. So this image itself is very large, so that's why it is. But then instead of all this code, and if I go here as well, and I think if I search Playwright images, yeah, Playwright YT Docker demo. So this is containers. We'll come to containers, but Playwright Docker YT demo. So if you see, this image is now shown up. Now we have the code which is bundled and a Docker image is ready. Now how to run this? What to do next? It's very simple. Docker run, not Docker run. Let me actually clear this. Docker run -it. -it is interactive, so what I think we don't we can, if you're from a Linux, so if you spawn up the image of a Linux machine and you want to log into physically into the Linux machine or MySQL database, -it is the interactive flag which allows you to log into that. And the name of the image, what's the name of the image, man? Copy image, Playwright Docker YT demo. Should have given it Playwright Docker YT demo. Should have given it something simpler. Playwright Docker run, and we have to give it the command. So you can specify a command here, but we have not done that. And then what you can do is pytest-v. And if you see, now this platform is changed to Linux, because obviously if you noticed here, this is based on Ubuntu, and that's why the platform is changed to Linux, and all the tests are still passing. So now what any tester, any team member, any business person, no matter who it is, instead of having to go over this entire setup, they can just pull this image. Obviously you have to push it to the registry first. It's still on your local, but you can push it. They can download this image and then run the test cases seamlessly. No need to make a single line of change in any of this code, and they don't have to worry about any of the setup. So this is the most important stuff about Docker. Everything you've written so far, this much code has been containerized or put together or bundled together. I wish I could add those, like, what is these Naruto like effects, and they've been bundled together using this, like 12 1 2 3 4 8 lines of code. Using 8 lines, all this left hand side pane is bundled together. Yeah, super stuff. So that is there. Now all the tests are still running, and all the tests have been run on platform Linux. Yeah, so this is there. So this is about Docker. And so yeah, now this running bit. Okay, so this was the Docker image. So we saw that this is the image, but container. So this running instance of this app or running instance of this image is called as Docker container. So Docker ps. So no container is running, but if I do Docker ps -a psa, I think Docker ps-a, yeah, it will show you the historically running instances. Now what I'll do is I'll run this again, and if I come here and I do Docker ps, if you see one container is running up 4 seconds, and it gives it a name as well too. So whatever this application or container is, it gives us a name as well. If you see, it's running the container. Pretty handy, super stuff. Now while this container is running, I want to take your attention that back to the utilities. Now here we have written these tests to run by default on local. If you don't get the environment file, so run it on local. But how do you get, and apart from that, we are also using this platform browser, these other environment variables as well. How do you get these environment variables? Very simple. You have to have an environment file. It's called secrets.env. Now this file is secret. I'm not going to open it up, yeah, because it's secret. Obviously I cannot show it to you, right? What it has, nothing much, but the only credentially part about this is my profile from the LambdaTest. So the credentials for accessing this platform are stored in the secrets.env. Now how do we run this? Now if I want to run these tests on local, then what I can do is local, by default it runs on local. But if I want to pass this environment file to this Docker container, actually I think this is finished now, and if I do Docker ps one more time, so no more container because the process is finished. And if I do Docker ps-a, all the historical runs are also shown. Funny McLaren, not fuzzy, but nice thing. Right. Now what? Now what? I think Docker Compose is remaining, but I think yeah, we're talking about the environment files. Pretty important stuff. How to pass the environment file to a Docker image. Actually, this is becoming a Docker tutorial only. I can rebrand this as a Docker tutorial, but I won't. We have to go over the basics a bit. This is for people who already have some knowledge of Docker. How to pass the secrets.env. Now, what we'll do is, in the secrets.env, let me configure the cloud run. So basically, we'll run the test case now on the this cloud grid, and we'll use, instead of Windows, we'll use macOS, fancy stuff. So let's go back to running on cloud. This bright white light is troubling me now. I've been recording for 1.5, not 1.5, but 2 hours, I think. But yeah, as promised, I've made the changes, and in the secrets.env file, super secret file, please don't, I cannot open the secrets.env file, has some important stuff. But yeah, so instead of secrets, this run on has been configured to run on cloud. So the job then remains. Actually, let me run this Playwright Docker demo build for live white demo. White is YouTube if you haven't guessed it. Yeah, let me modify this. Oh my god, what happened? Yeah, it's still there. Yeah, and now we're going to run this on cloud. How to do it? Just the same, docker run -it playwright docker pytest -v, and instead of --env -py and secrets.env. 8 items collected, and now if you see Playwright Docker build demo, macOS, and so if you see, if you cannot see, I think let me zoom it. Yeah, macOS and WebKit. Tests are passed. Now, the thing with this is, if you're running this on the cloud grid, sometimes the connection might be a little bit less stable. So you might get some of these cancel tests on, but that is not a problem. The aim was to show that, okay, these tests can be run on cloud using --env file by passing it the configuration variables. And similarly, so the tests are still running. I think some of the tests, this one, okay, it's not actually, some of them are passed, some of them cancelled. Similarly, let me cancel this actually, CLS. And similarly, if you want to run the tests in parallel, num processes, and say three tests at a time. And if you see, 3 tests are queued. So if you see, 3 tests are running in parallel. Before this, we are running one by one, but you can run them in parallel as well. And for a pass test, okay, so there was some connection, definitely some connection error. So let's see if one of them succeeds. So search button is visible, passed. You can also play this entire thing. This is actually super stuff. So I don't have a Mac machine, but I can actually use the entire cloud grid infrastructure provided by LambdaTest, and I can just reuse it as it is. So super stuff. So if you see, the test has run entirely. I can actually zoom it, and so it will show you the entire process, what it's doing. So if you see, yeah, super stuff. And screenshots are also available, videos are also available. You can download this whole thing. And where did it go? So yeah, so 6 tests have passed, 2 have failed, but I think that is just due to connection error, so that is okay. So this is about Docker. This is about Docker and how tests can be Dockerized. And as a bonus, we also saw how we can run it on the cloud platform. The important point being, you can use an environment file to control this, and then environment file to control where your tests go. So that is another best practice which we used. So run it on local, run it on cloud, and stuff like that. So write your test cases, write your code, be free of worry, and then Dockerize it. Create an image. From an image, spawn up containers, spawn up containers, and start using it. That is the beauty of Docker. That is the beauty of containerization technologies. So I think Docker was the pioneer back in 2013, 2012, 2013. But since then, many players have come in. Rancher Desktop is one, Podman, I think stuff like that. People like that are now, and also all the cloud providers have their own container runtimes, which is available. So you don't essentially need Docker. You just need some container solution to be able to containerize your application, and there are many which are available. One last bit before I leave you now. So we do this docker run command every time. So this is nice if we have one container or one application which is running. Imagine if you have hundreds of applications. So you're setting up a web application which is based on Flask, which needs an Nginx, which needs, say, maybe firewalls and stuff like that, and then it needs the test site. So basically you're setting up the whole application setup. So would you do this docker run every time to run one container? No. Then what you can do is use Docker Compose. So Docker Compose is a special type of file, again similar to build an image. We add a Docker file to build like containers, to initialize a lot of services using containers, or initialize a lot of containers. You have the Docker Compose. The first one is the version of this Docker Compose. This keeps on changing. Please be careful. Check out the latest version which is supported. And then the services. So because we only have one, and the image, we have the Playwright Docker. But for our case, I think what you can do is Playwright Docker YT demo, Playwright Docker -YT demo. And then instead of passing the env file like this, what you can do is pass it here. Nice and easy peasy. So that is, and you can write as many services as you want here. And then you can, in a single command, which is Docker Compose up. You see, Docker Compose up. Now the thing which happened here is we don't have a default command here. So if I just give a default command to this, where did the Docker file go? Here. Yeah. cmd and pytest -v. Yeah. Now I'll do the not Docker, but Docker build -d Playwright Docker -YT demo and dot. So we have specified a default command that, okay, whenever we are whenever this image is prepared, fire this command. Okay, now we're using this Docker Compose, this same image, and then if I do Docker Compose up, okay, so /sh is missing, something is missing here, pytest -v, I think the comma is missing. Docker build, and let's try Docker Compose up again. Yeah, the comma was missing. So if you see, 8 tests are running. So instead of writing the Docker run everything and passing the environment file, we can do it within the single command called as Docker Compose up. Now, whether to use it or not for production, I think there's a debate about that. There's some Stack Overflow discussions which I'll leave a link to, but that is a different topic. But you can write all your services in a Docker Compose YAML, and then those services can be started up using Docker Compose up. So that's about Docker Compose.